the Yes to Life show on UK Health Radio. I'm Robin Daly, host for the show and founder of Yes to Life, the UK's integrative cancer care charity. Today's show is the concluding episode in a 6-part investigation into the novel thinking around the origin and mechanisms of cancer that Mark Lintern has developed through a very long process of research. I'm speaking to Mark over the internet. Hi Mark, welcome back for the last instalment of Cancer Through Another Lens, the story of your 8+ year journey into the heart of cancer, its mechanisms, its origin.
Hi Robin, thank you for having me.
So, in this final episode, we're going to move out again into the wider world of science and, finally, the public at large. So, this part 6 is what's proved to be a long story, but one that's got plenty of important details, being well worth spending the time on. So, anybody who's just joining us at part 6, I strongly advise you to look up the other episodes. They're all available on Listen On Demand. Start from the beginning. It's definitely a story worth hearing. So we're going to start out this last episode by zooming in on your thinking process, just to demonstrate the way your researches went, how they led you forward, the kind of suppositions that you had to confront, and how you arrived at the kind of conclusions you did. So for this, you wanted to take one of the hallmarks of cancer that we've discussed much in the episodes. This is number 5, I believe. Which is the hallmark about angiogenesis, or the spread of blood vessels by tumours into the surrounding tissue in order to increase their nutrition. So, launch straight in and tell us how you set about investigating the cause of angiogenesis.
Okay, so angiogenesis is where obviously the tumour grows out of control. It outgrows the current blood supply that is there. So in order for the tumour to carry on growing, it needs nutrients. So it instigates blood vessel growth, stimulates this growth, and that allows the nutrients to feed the disease, and it grows and continues to grow these blood vessels. So this is one of the key hallmarks of the 10 that scientists are looking at. And under the current paradigm, and with these 10 hallmarks, mainstream medicine wants to target those specific aspects, and they do so by creating drugs which try and block the blood vessel process. Now, as I was researching this aspect of the disease, I wanted to determine why angiogenesis was occurring. And when you look at the literature, the focus is on a particular growth factor, VEGF, vascular endothelial growth factor. Now, in tumours, this is upregulated, and this stimulates the blood vessel growth that occurs. So scientists are looking at this, and they're making drugs to target a particular growth factor in order to block it. Now, my question was, when I was looking at this, was, that's great, but surely if we want to maybe better treat the disease, we need to understand the underlying cause, or the driving mechanism, the origin. Once you find the origin and you target that, there's no need to target all these different aspects independently. So I was asking the question in my own head at the time, what causes the upregulation of VEGF? But I couldn't really find much information about it, because the focus again was on just drugs to block this particular process. Now, this can be particularly damaging, because you're trying to block a process which is naturally occurring in the body and needed for healthy function. So these drugs can't be used for a long time. But I thought, well, why aren't a lot of these scientists asking the question, what is the upstream cause of this? And I could only put it down to the fact that the mainstream view of the disease at the moment is that tumours develop a mind of their own. So this is this idea that I've spoken about previously, that they've developed autonomy, and they choose basically to upregulate this VEGF growth factor, essentially. And when you think along those lines, there's no need to then further investigate the cause of it, because you believe the cause is the fact that the personality of the tumour instigates this upregulation. So the target then, the goal then is just to try and target it and block it. But I wasn't happy with this because I wanted to try and see if there was an origin to the disease. And so I started looking at the literature, and when it was being described about what potentially causes this upregulation in VEGF, hypoxia was one. Because when cells become damaged, they potentially lose their oxygen supply as well as their blood supply. So you get this switch in energy to glycolysis. And that was shown to instigate angiogenesis. So at this point, I'm trying to figure out the process, and I'm realizing that this means that actually glycolysis generates angiogenesis. But how does that occur? Well, the byproduct of glycolysis is lactic acid. And then I did more research and discovered that lactic acid actually stimulates angiogenesis. Now, this shocked me a little bit because this translates into the metabolic theory side of it, in that the metabolic theory is highlighting that abnormal metabolism where cancer cells are reliant on glycolysis seems to be a major issue associated with cancer and driving most of the disease. Well, this appears to be actually true because the byproduct of abnormal metabolism is lactic acid, which then would explain the growth of blood vessels through the upregulation of VEGF. Because this is a natural process. So, like I said, for instance, if part of your tissue becomes damaged, you get punched, you get kicked for whatever reason, you're playing a sport and it's quite physical, you will lose the blood vessel access to the cell. So oxygen will be restricted. So the backup on energy system of glycolysis will be instigated. In that process of cell repair, you have this abundant expression of lactic acid. So the body has learned at this point that when lactic acid is being produced, it's being produced for either a reason that damage has occurred or that the oxygen supply isn't sufficient. So it naturally is lactic acid production or overproduction of lactic acid as a marker to change the cellular environment so that blood vessels can grow to either the damaged tissue or the blood supply can be increased to improve the fitness of the person who is producing the lactic acid. So an athlete, for instance, will, if they're sprinting a lot and they're really pushing their bodies, they will also utilize glycolysis to support their primary energy system because the oxygen supply might not be good enough to supply them with the energy they need. So depending on how intense the exercise is, they will be producing a certain level of lactic acid. That then stimulates blood vessel growth, which is the reason why athletes' blood vessels are so prominent. And that is evolution in action, essentially. So the body is improving the physiology of the athlete based upon the amount of lactic acid being produced because it's inefficient and it's corrosive. The body uses that to improve the fitness of the athlete. So the next time the athlete exercises, more oxygen will be driven by the increased vascular system that has occurred as a result of there being too much lactic acid being produced because the athlete is relying too heavily on glycolysis. So next time, the athlete doesn't use glycolysis so much. Mitochondria are also increased to process the extra oxygen that the new blood supply can deliver. So your fitness increases. It's a natural progression in biology of how the human body works. So when I understood that, I realized that VEGF was upregulated because lactic acid was being produced in abundance because cancer cells rely on glycolysis. And the metabolic theory was highlighting this through the fact that the Warburg effect occurs in tumours. So this process is already beginning to explain the upregulation of VEGF and blood vessel growth. And I was stepping back from this. I was a bit miffed as to why proponents of the somatic mutation theory were still struggling to explain why and how blood vessel growth occurred, because they couldn't find a particular DNA gene that was mutated to explain this process. But quite simply, it's explained through metabolism. Okay, I looked at the metabolic theory. What's the cause of this metabolic abnormality, this Warburg effect? And of course, Professor Seyfried suggested that it's defective oxphos. I was on board with that for a while until I discovered that there's contention over that because several of the scientists have highlighted that oxphos is still occurring. So it doesn't look like there's actually a malfunction of mitochondria that is driving this switch in energy system. So then that led me, okay, what's the cause? What is the other cause of that? I then looked at all the other several other aspects that can explain, or behaviors that can explain the instigation of glycolysis, such as insulin resistance. But then I found with insulin resistance and various other factors that could explain this transition to glycolysis, couldn't explain it in its entirety. So insulin resistance is only present in approximately 60% of patients. So that got me asking, what was the underlying mechanism driving the Warburg effect in the other 40%? And of course, I'm all this time being driven to find a common cause. And then I hit on the evidence that infection caused the Warburg effect. And I thought, this is interesting. So now we have infection causing the Warburg effect, potentially stimulating lactic acid production if the infection persists, and then that can explain hallmark 5, angiogenesis. But then the question would be upstream from that, well, for that thinking to be correct, pathogens would need to be present in tumours. And tumours at that period of time were thought to be sterile, do not contain microorganisms, until Ravitch Straussman and colleagues highlighted that actually when they investigated tumours, that microorganisms are present in all cancers and all tumours. Pathogenic intracellular microorganisms are present. So now when I discovered that, I realised, okay, we're going somewhere here, my thinking, because the microorganisms are present in these tumours that need to be there if I'm claiming that infection or particular type of infection is driving the Warburg effect and therefore the rest of the conditions of cancer. But then from there, there's always the question of, well, a tumour could develop first and then be populated by microorganisms after the event. So the microorganisms might not actually be driving the disease. So I had that other problem to kind of think about. But then when you take it that step further, you realise, okay, so what's the initial stages of cancer that need to be explained? And the main factor is inflammation. So how can this relate to where I'm going with my thinking? Well, there's certain receptors on the cell that are initiated or overstimulated in cancer called toll-like receptors. Now, these toll-like receptors initiate inflammation in the cell, and they are also being targeted by proponents of mainstream medicine and DNA theory in order to create drugs to block them or stimulate them. Now, here's the interesting thing. These toll-like receptors are specific receptors that are designed to identify and react to pathogens, infection, effectively. And they react in a way that stimulates both glycolysis, the Warburg effect, and specifically inflammation. The idea of this is to trigger the immune system for help in eradicating the infectious agent. So here we now have, I've gone through the process of infection can cause the Warburg effect, can explain that part of that hallmark of the disease, which is one of the key hallmarks, to then highlighting that these infectious agents are present in all tumours. So the dogma of tumours being sterile has now, so they are present and potentially under the underlying mechanism driving the Warburg effect. But now we have this extra evidence right at the beginning of cancer development, before it's developed, because it's accepted that chronic inflammation instigates cancer. Now, these toll-like receptors are upregulated, suggests that because their primary function is to identify pathogens, suggests that they are upregulated because pathogens are present, and they then instigate inflammation, the precursor to cancer. So, looking back at this process, my logical mode of thinking back from trying to explain angiogenesis, when you go back and try and consider the cause of the cause of the cause of the cause, my idea was to try and identify the origin of the disease through this process of moving back upstream to see if I can find something that follows on all the way downstream. And I have been able to find through this process of looking at infection that everything seems to point towards this notion, even right at the beginning, with this instigation of these toll-like receptors, highlighting that infectious agents are present at the beginning of cancer, and therefore this adds weight to the proposition that these particularly infectious pathogens are driving the disease.
UK Health Radio, the station that makes you feel good. UK Health Radio, the station that makes you feel good.
Oh, interesting. So, particularly the point that you're saying that drug manufacturers are trying to target these receptors, and what's their thinking? Is it because inflammation is one of the hallmarks? Is that the reason they're trying to do it?
Yeah, I suppose so. So inflammation is seen as the primary instigator of cancer, as well as many other diseases. So many will probably look at inflammation, and I think the idea is, with this whole process of not considering the microorganism, but thinking that the cell has got a mind of its own, is that the cell is triggering these toll-like receptors on purpose to instigate inflammation, or that possibly there has been an infectious agent that has instigated these toll-like receptors, but that infectious agent has then been dealt with, but then damage has occurred to these toll-like receptors, and they are stuck in the on position, which triggers the inflammation. And then that inflammation causes the damage that then develops its own bite.
So it highlights a difference between your thinking and the general mainstream thinking, which has come up several times, which is that the mainstream thinking says, oh, something's gone wrong here, whereas your thinking says, no, this process is probably happening for a good reason. This is probably the body doing the right thing. And if you start knocking that out with drugs, you're actually not helping the body to do its job.
No, not if a pathogen is present, as we've seen in Straussman's work. If the pathogen is present, all you're doing by blocking or stopping the inflammation is you're going to reduce the cell damage that is occurring through the inflammation process, but you're reducing the ability of the cell to combat the pathogen, which is why possibly we see that intracellular pathogens are present in all tumours.
Okay, well, look, very interesting little zoom in on one part of your research, which you've summarised it very nicely. It probably took you months, but interesting to see your thinking running through all that, and how everything links together in that way. And you've continually moved backwards up the chain to try and find out where it's all coming from. So we finished last week at the point where you'd made the decision that you found enough answers that were sufficiently satisfying to you that you decided the time had come to take them out into the world and find out what other scientists made of them. And at that point, you were 7 years into your journey, so I can imagine some very mixed feelings going on in you about taking that step. Excitement, yes, but surely also trepidation. So coming from such an unorthodox direction, there was no real tried and tested route to bring your findings forward. What did you decide to do?
Well, I knew that the evidence within the book could speak for itself to a certain degree, but I felt that I needed endorsement, because I didn't think anyone was going to listen to me without an endorsement from medical professionals, being as though I'm a lay person by trade. So I thought, well, part of my strategy would be to contact several scientists, get them to have a look at the theory, and hopefully provide an endorsement, so that I could then publish the book and take it from there. So I contacted several scientists, and I didn't get much of a response. I got an initial response from a number of them. However, I was having an issue when it got to a certain point where they would ask me my background, what university I was from or what medical institution I was from, because my ideas were very interesting. But then I had to come clean and say that I was, a layperson who'd taken on board this mantle of research myself, and then it all went quiet. Now, part of my research also was various other organisations, of which you were the primary one to contact if these other avenues had failed. Because I'd previously seen you conversing in other blogs and seeing what the charity was about. And I could see that you had an objective view to the disease and its treatment. You weren't wholly in one realm or the other. You were looking at both the conventional side and the alternative side and trying to marry those up together in what I thought was a logical way of doing things, a logical way of looking at the disease. So I had confidence that you would view my initial request when I contacted you with intrigue enough to hear me talk about my theory and put my point across.
Right. Yeah, so I got a letter arrived through the post, new cancer theory. So I don't get every day, I've got to say. But, in it you introduce yourself and say what you've been doing, and in the introductory paragraph you say, effectively, I've potentially identified the underlying cause, which is not caused by DNA damage or mutation. The somatic mutation theory is wrong, which is something else I also confirm. Potentially, I've solved cancer. Well, as I say, this is not a kind of letter I get every day. And so certainly interesting, and I have to admit that I welcomed your ideas initially with a healthy dose of scepticism. It was, after all, a pretty unlikely scenario, though untrained researcher coming up with answers in the field that was, I was all too painfully aware that rife with partial and conflicting science. And, of course, it's taken up the attention of some of the greatest minds in science for lifetimes. Anyway, you finish up your letter saying, I'm not getting much luck from the scientists who seem stuck in the DNA-based mindset, most of which refuse to even contemplate the notion that DNA isn't responsible, so I appear to be hitting a brick wall even before scientists have analysed the evidence. Anyway, it was the start of a year and a half's worth of calls and an immense amount of work, which was all leading up to a particular point, which is a plan that we hashed together for how to present your ideas to the wider world. And that was an event that took place on the 12th of February this year. So do you want to say what the intention of the event was?
Yeah, well, after I presented my information to you, you proposed that in order for my thinking to be accepted or for it to hold any weight or value, it would need to be scrutinised. And you then put forward this platform, which occurred on the 12th of February, whereby I would be presenting my hypothesis to a group of cancer experts, and they would scrutinise the evidence that I put forward and my hypothesis to see if it held any weight. It was a scary proposition when you put it forward at the end of those 4 hours. But I knew that it was something that I had to undergo in order to have my ideas scrutinised in the correct scientific manner. At the end of the day, that's what science is.
Right, absolutely. So maybe you want to tell us about the format of the event and who was involved.
Yeah, the format event took, it was about 6 hours long, and it took the form of 3 presentations where I broke down each argument of my thinking, targeting the issues surrounding the current theories of cancer, and several flaws that were present in them, which led me to think along the lines of searching for an underlying mechanism. The second presentation then touched on a particular aspect of the disease that can potentially identify the underlying cause, and I explained the difference between my cell suppression model compared to the cell malfunction model, which was encompassing all of pretty much mainstream theories. And then the third presentation was about the specific microorganisms that I was identifying as the underlying driver of that cell suppression mechanism. And in between these presentations, you'd set up the process of allowing for questions and answers to be put forward after each presentation from the expert panel. So we had 3 panels of experts. On the expert science panel, we have Professor Michael Lisanti. He's currently the chair of translational medicine at Salford University and is listed amongst the top 100 most cited researchers in biochemistry and biology. We have Dr. William Lavalley, who was appointed by the Canadian Federal Minister of Health to the Expert Advisory Committee of the Natural Health Products Directorate. He's a scientist and clinician. We have Professor Bridget Koenig, who's Professor of Medical Microbiology and Virology, Infectious Immunology and Infectious Epidemiology. Dr. Ahmed El-Saka, who is Senior Researcher and Medical Director of the Egyptian Foundation for Research and Community Development. On the expert clinicians panel, we have Dr. Naisha Winters, who is well known from this show, naturopathic medical doctor who has written the book, The Metabolic Approach to Cancer. We have Dr. Sean Devlin, who holds a master's degree in biochemistry and has pursued doctoral studies in pharmacology. And Dr. Penny Kehaoglu, who is a senior consultant clinical oncologist. On our expert patient panel, we have Jane McClelland, who authored the book How to Starve Cancer and doing amazing work in the field of cancer treatment, looking at repurposed drugs and the pathways that are involved there. So we have Daniel Stanchu, who founded the MCS Foundation for Life, a non-profit organisation supporting treatments within cancer. And we have Mark Sean Taylor, who is the founder of Patient-Led Oncology, a movement set up to improve human data access and safety regarding integrative cancer treatment.
One other important aspect to the whole event was that there was an opportunity for the audience and the panel to engage with each step of your presentations.
Yes, this was key, really. We designed a set of polls, around 26, I think they were, that were engaging with each aspect of the hypothesis I was putting forward and registering their confidence vote in that any statement I was making surrounding my hypothesis at that time.
Yeah, so that's kind of the meat of the whole matter, in that we got a massive amount of data from it as to what people thought about each of the logical steps of your argument. So it's kind of hard to imagine being out there suddenly exposing your precious, hard-won ideas to the dazzling light of some of the brightest minds in cancer. I imagine you rehearsed that scene 1,000,000 times in your mind over the previous 8+ years. What was it actually like?
Very scary indeed. But in the end, it did surpass my expectations, which was great. It was stressful, but it was needed, and I embraced the challenge, really, and enjoyed it throughout.
UK Health Radio, the station that makes you feel good. UK Health Radio, the station that makes you feel good.
Well, that's good. So, as I said, we got this polling going on all the time. So that was really helpful in terms of knowing in detail what people thought about each specific aspect of your findings. And so, in general, how do you feel your ideas were received?
I was pleasantly surprised. I didn't actually think I would receive the response that I did. I knew I'd done the research and I knew I had the evidence to support my findings. However, there's always an unknown. I'm not a scientist myself, so there's always going to be something there that I may not have thought of. However, I was still conscious that the ideas that I was putting forward were quite radical, and even with the evidence being presented and in the manner that we presented it was quite a quick set of presentations, a lot of information to take on board, and many of the scientists and people that were there were fantastic in the sense that they were incredibly objective and listened intently to everything I said, which would have been difficult to take on board in such a short space of time, given their medical background and training that led them to believe or think in a particular way. So hats off to everyone who was present for having the inclination to listen to someone as myself present these ideas. But I was pleasantly surprised, because I thought that I would get a bit more resistance. Most of the experts on the panel were incredibly open-minded and very supportive of quite a number of the poles and areas of thinking that I presented.
It's interesting, isn't it? Well, quite a lot of the planning, if you like, the thinking behind the event went, if you look in the steps from, you have mainstream science, DNA theory, and then you have the kind of competing, growing science, the metabolic theory, which is beginning to gain proper traction now, is being investigated by people in respected institutions now, as not so much seen as completely outside. And, I think we realized early on that the hike to go directly from the somatic mutation, the DNA theory, to yours was simply a step too far. It would be for most people. If they hadn't managed to incorporate metabolic thinking yet, that to go the extra mile and get to your thinking was probably impossible. So the people who were there, largely speaking, had already embraced metabolic science. Didn't mean it wasn't a challenge what you were putting forward, because it actually, did question some very fundamental things about metabolic science as well. But I think you can say it encapsulates metabolic thinking to quite a large degree, your view of things, in a way that DNA theory is relegated to a minor kind of symptom, if you like. The DNA damage that's thought to be the cause is seen as very much a symptom and not an actual cause. So, hence, it was a welcoming environment to some extent for people who are metabolic supporters, but not so much so for the DNA. But it was a pleasant surprise, wasn't it? I agree with you that people in the main seemed to be open to making the steps involved.
Yeah, specifically because the detail near the end of my third presentation about infection, there seems to be quite a lot of controversy about that, because in the realm of cancer science, infection is already seen as part of the disease. 20% of infection is causing cancer. However, it was making the transition between showing that infection, as it's currently seen, is through a cell malfunction lens, and then highlighting that I was looking through this different lens of cell suppression, where infectious agents, not specifically the ones that are already accepted, but other infectious agents that possibly haven't been really considered, are controlling specific mechanisms in a completely different way to how people have perceived them in the past.
Right.
So, while I was on board with the metabolic theory for sure, what I've essentially done is just looked at a different way to explain the Warburg effect through this infectious mechanism, where infection generates the Warburg effect. So I'm in league with the metabolic theory. It drives, clearly abnormal metabolism is driving the disease, but the only distinction I'm really making from that perspective is that this infectious agent is underlying the cause of the Warburg effect and then driving the rest of the disease as such. So I don't suppose it was so much of a leap for metabolic scientists. But again, infection is controversial for that reason, that it's already been explored and assumed that it's because of a malfunction to the cell. And I think even in the metabolic camp, many still think they recognize the abnormal metabolism that occurs, obviously, but it's again through this mechanism of cell malfunction. So the concept I was then pushing forward with this cell suppression paradigm was quite a large leap, to say. And then for the somatic mutation theory proponents, it's going to be an even bigger leap, if not even on board with a metabolic theory as such. So I can see why that would have been quite difficult.
Yeah, one of the difficulties in presenting your ideas is actually getting past the barrier of the known. As you say, if you mention something like infection, it's like, oh yeah, we know about that. It's already known to be one of the things that causes cancer. But in many ways, one of the most confrontational aspects of your presentation was actually challenging the idea that cancer is multifactorial. Because that's where this stuff all hangs out. Yeah, we know about that. It's one of the many factors. But if you're actually saying, no, it's not multifactorial, that's actually the brakes are on at that point. Wait a minute. That needs some explaining. And so it was very interesting to see how that was received.
Yeah, I think it was received really well as well. I think a lot of it really helped with the planning that we did previously. You've guided me on a lot of this journey that we've been on. And one of the key aspects we both looked at was this idea of how to present this information in a non-combative way that would cause the brakes to come on. So one of the big focus for me was trying to present this information in a way that was progressive and open, in a way for people to accept, rather than combative and I've presented this idea, I know best kind of thing, because at the end of the day, I don't know best. I'm just going along what the evidence is provided me, and then interpreting that in a particular way and just hoping that it resonates with other people. So it was very nice to have so many objective scientists, clinicians, and patient experts there willing to just be open-minded and listen to the change in perspective. Possibility of it.
Well, for myself, it was a bit of a personal journey in terms of creating the event, is that I have a huge distaste for conventional science and the way that it's conducted, which is that anybody brave enough stands up, says something new, and then waits to get shot down. And is totally unpleasant, abusive system, as far as I'm concerned. And it's not conducive to finding out the answers at all, I don't think. I think the course of cancer science proves pretty well that it doesn't work. It just delays progress. So part of what I had to say at the outset of the event was about collaboration and about the dire need for collaboration if we're to actually make real progress. And I was very heartened by the response of people there who actually really appreciated that aspect of it, that it wasn't combative at all, that it was, the scientific interest was to the fore. And, this particular mention was made several times of the fact that it wasn't just a group of cancer researchers here, the clinicians were there as well. And so straight away you got the mixture between the theoretical, if you like, in the lab and the real world of the clinician who's dealing with real people with cancer. And that's a really important bridge to cross if you want to make progress. So many things never make it successfully from the lab to the bedside, so to speak.
But also the expert patient panel that was
absolutely.
The views of those experts as well. And I think that's where your thinking really shone with this event, in that I was quite surprised, actually, not being in the scientific field, that so many medical professionals in the audience and chat were were so not surprised that they were so complimentary of the event and how it was put forward, but I was surprised that they were surprised at how that the event was taking this format, because I would assume that this is how science should really be conducted.
Absolutely.
And in the manner you presented. But again, a part of the presentation, we discussed the notion that disciplines are siloed and they don't necessarily communicate very well together, where I'm confident in where we were taking this because the platform was so objective and had many different disciplines talking together. And that's the way the science needs to be conducted, in my opinion.
Absolutely. Well, yeah, the patient experts, a crucial part of it. Well, not least of all because, well, what are you? A patient expert. That's exactly what you are. Somebody who's had cancer, wants to know more about it than you're being told, wants to understand it better, and has rolled up the sleeves and got on with it. And, the three panelists who are patient experts, all extraordinary experts, people who are contributing massively to the progress of cancer, in ways which are utterly different from any of the efforts within, the systematized cancer research community. And no less important, but because of the fact it's been done outside of the mainstream. In fact, in many ways, more important. So to have missed them out would have been ridiculous.
There's definitely something to be said for people who experience the disease in the manner that I did and the patient experts did. It forces, in a sense, you to not only question your own mortality, but that drives you to want to search and investigate more deeply. It certainly did for me, as done for Mark Sean Taylor, Jane McClelland, and Daniel Stanchu as well. So they're driven in a way, I suppose, that possibly some scientists aren't driven because they may not have experienced that. Obviously, some scientists will be driven in that context as well. But to have those patient experts there was an extra dimension that is much needed in the scientific field.
I think so. Yeah, it was very exciting. Anyway, it has produced calls from the people who attended for more, and it certainly set a seed for an idea to do other events in that spirit, to have open forum scientific investigations in a positive, constructive manner in that way. So, yeah, it's very exciting. So I thought I'd give a few little tasters of the results that came in, just to give people an idea. I mean, firstly, the average vote by all three panels across all 24 confidence polls that we had throughout the event ranged between 7 and 8 out of 10, which was an incredible result for the first airing of a new idea in such a contentious field. Audience votes were at the top end of that range as well, slightly more always than the panellists. The last two confidence polls were about the whole of your proposition. And the first of those said, Mark has presented a coherent model of carcinogenesis and the mechanism of cancer. And while overall this produced a mix of results, the average was high, and it attracted no less than a 10 from Professor Michael DeSanti, who you mentioned. He's one of the top researchers in the UK, as well as from Dr. Naisha Winters, well-known proponent of metabolic science. And the final poll for today's event has changed the parameters of cancer treatment and research. Again, reduced 10 from both Dr. Will LaValle, highly respected metabolic science research expert, and Dr. Naisha Winters. So, in summary, it's pretty spectacular and certainly sufficient for people to sit up and take some notice of your findings. So I wanted to mention that the presentations that you did, Mark, during the actual event are available, all of them, if you go to the Yes to Life website, yestolife.org.uk, and you click the link to the online store right at the very top of every page, you'll find you can get hold of those presentations bundled up with a nice little package of PDF, diagrams, references, all sorts of great science. So you can watch those yourself. They're video recording made by Mark. Also, just to say that we're not leaving it there in terms of this event. we do plan to go forward because there's a lot of enthusiasm from the audience and the panelists to actually work with Mark's ideas going forward. So we have a mailing list of practitioners now who are keen to take this forward. And what we're hoping to do is to create a bit of a forum ongoingly in order to put some of Mark's findings to the test, because this is what it's all about, really. It sounds good in theory, it certainly does to me, but as Mark, I'm sure you will attest, that's only one step of the way.
Yeah, the proof is in the pudding, really, and we need to test the hypothesis. In the end, the goal is to improve patient outcomes.
Yeah. So, we are hoping that we can get some patient trials underway. Maybe with some good collaboration, we can do kind of multi-center trials so the same protocols are being tried out in different places simultaneously. And if we can encourage some lab research as well, that would be even better. So that's kind of where we're looking to, as well as to engage lots of other people in the science behind the whole proposition, to get other input from key scientists. For example, some of the ones that you quote in your own presentations, the people who are working in the areas that you've been looking into. We would love to have their input as well. So maybe would you like to say something about where you hope that you might go with the theory?
Well, I've always wanted to be in discussion with key scientists in the area, just to push the envelope of cancer science, really. I'd love to collaborate with anyone in particular who would like to engage with these ideas and possibly, like you say, instigate studies that can test the hypothesis and test particular treatments, which I think can work alongside conventional treatments as they currently are. They just need to be carefully considered by a medical professional. But yeah, certainly it's a case of wanting to carry this forward and push these ideas out there. So at the moment, I'm close to finalising my book, and I'm taking on board a lot of the information that was presented to me in the event and some of the comments made by key scientists, and incorporating that into the book to ensure that I'm being objective and looking at cancer from all the different angles that were presented on the day. So my book will be out there fairly soon, and you'll be able to go through that, all the evidence and the logical steps of thinking that drew me to this inevitable conclusion.
But so I just wanted to make the point that even though we spent 6 episodes of the show talking about this is a bit like the difference between going to a movie and reading the book. The amount of detail in your book surpasses anything we've spoken about by miles, with an extraordinary level of referencing as well. So if you really want to get involved in Mark's thinking, you need the book. And we will, of course, announce when it comes out. Meanwhile, if you're desperate, there is an excerpt from the book, a good excerpt, a chunky one, available again from the Yes to Life online store. So you can purchase that if you want to. So big thanks to you for taking the time to go into your story in such depth over the last few weeks. To me, it's a story that really needs telling. It's got enormous promise when it comes to turning the tide on the relentless increase in cases of cancer. We're certainly in need of some new leads to follow. The direction of research for the last few decades has delivered very little for immense investment. So, as I pointed out during the shows, I'm a huge fan of common sense in regards to health. And I have to say, for me, your proposition for cancer delivers far more on the common sense scale than anything else I've heard so far. So it's really heartening. You've had some decisive support so far, but I sense that the next stage of your journey to have an impact on cancer is only just beginning. So I give you my very best wishes for it.
Thank you very much, Robin, and thank you for everything you've done for me. It's really heartening to hear you say what you've. It's nice now to come full circle and have this conclusion drawn, so we can have a platform to move forward on. And I can't thank you enough for everything you've done. So I really appreciate all your help and guidance.
It's been an absolute pleasure. It's been one of the most exciting things I've done with Yes to Life. Certainly never anticipated putting out a new mechanism for cancer. That wasn't something in my plans, but along it came, and it's been great, very exciting.
Well, I never anticipated people would take it on board as much as they did. So yes, now for me it is really, really exciting.
Okay, onward.
Thank you, Robin.
Bye-bye. Bye. I do hope you found this series of shows both helpful and interesting. Remember, they're all available on Listen On Demand, as well as in podcast format, if you want to re-listen to any, and also that further resources relevant to Mark's hypothesis are available from the Yes to Life online store, which you can access via the Yes to Life website. That's yestolife.org.uk. Many thanks for listening. I look forward to bringing you another Yes to Life show next week here on UK Health Radio. Goodbye.